Hey there, folks. In section 3.5, there's a section of problems where you're asked to use the method of undetermined coefficients to find a solution to the non-homogeneous problem. And they suggest that you use a computer algebra system to help you find a particular solution. I'm going to kind of walk you through two different approaches. One slightly more complicated that maybe will illustrate how one can use cocalc to do this work as an assistant, like an algebraic assistant, and one how to, and then again how to use cocalc to just solve the darn problem. So part A is asking you to find a suitable form for y of t. Let's do that first. So I'm going to use this problem just so I'm not doing somebody's homework problem for them. On the left hand side I've got y double prime plus 4y, and on the right hand side I have this non-homogeneous term. Remember that the method of undetermined coefficients requires you to break up signs, trig functions, and polynomials, separate them from each other. So I see two different kinds of trig functions. I have a 2x and an x here as an argument to cosine, so I've got to treat these separately. And then I've got these two polynomial terms, but I can smush them together as a single second order polynomial in the method of undetermined coefficients. So we're going to do three pieces here. G1, and again I'm using the notation from table 3.5.1 in your book. G1 is 4 cosine 2x, G2 is 6 cosine x, G3 is this full polynomial, full second order polynomial. If you go ahead and compute the characteristic polynomial of the left hand side homogeneous differential equation, you get this characteristic polynomial r squared plus 4 equals 0 with roots plus or minus 2i, complex roots. All right, now y1 is the undetermined coefficients general form for G1, and if you look, beta here is 2, and 2 a plus I beta is a root of this polynomial. In particular, 2i is a root. So we've got to add an extra factor of x here. I'm working in the variable x instead of t. We've got to add an extra factor of x here, but then the rest of it is just a constant times cosine 2x plus a constant times sine 2x. That's the general form of the undetermined coefficients guess for the first term. For the second term, beta here is 1, alpha is 0. Alpha plus I beta is not a root of this differential equation, so we don't need this extra factor in the second piece of this. So here we just have a constant times cosine x plus a constant times sine x. And the third thing is a second order polynomial. And since 0 is not a root of the characteristic polynomial, we don't need an extra factor of x. And we end up with just a generic second order equation, c0 plus c1x plus c2x squared. It's at this point that I would jump over to cocalc and do each of these three pieces separately. I would ask cocalc to compute the derivatives of this and substitute it into the differential equation. So let me jump over to cocalc here. So y1, I declare the variables that are on the right hand side of y1, in particular x, a0, and a1. And then I substitute them into the differential equation. So this is the notation for computing the second derivative of y1. And then this is 4 times y1. Add those together, set them equal to the right hand side, 4 cosine 2x. And then just let cocalc do the work for you. And I end up with this equation, which I'm going to cut and paste back into my notebook. So here's the equation. Now what do? I equate like terms. So on the left hand side I've got a cosine 2x, on the right hand side I've got a cosine 2x. The coefficients on those two terms have to equal. In other words, 4a1 had better equal 4, which means a1 needs to be 1. The other term, the coefficient on the sine 2x, has to match the coefficient on the sine 2x. There is no sine 2x term on the right hand side, which means this coefficient needs to be 0, which tells me that a0 is equal to 0. So I now know that a0 is equal to 0 and a1 is equal to 1, and I take those values and I plug them back in up here, and I discover a0 equals 0, a1 equals 1, that y1 is x sine 2x. And I've underlined that in green as the first part of the undetermined coefficient solution for the non-homogeneous problem. I repeat this exercise for the second guess, b cosine x plus b1 sine x. Let me jump back over to cocalc. I declare those variables, x, b0, and b1. I build y2. I substitute into the differential equation, and then I show the simplified equation, and I get something like this. I'm going to cut and paste that back into my notebook, and I'm down here. And then I do the same thing. I equate the cosine terms, and I see that 3b0 better equals 6, and 3b1 better equals 0. From that I learned that b0 is 2 and b1 is 0. So I take that 2 and I put it in up here for b0, and that 0 put it up here for b1. And I end up with the second part of the non-homogeneous solution, namely 2 cosine x. Last case, we have this quadratic term. I'll jump over to cocalc again. I set up y3 as c0 plus c1x plus c2x squared. I stick it in the differential equation. I put the right-hand side over there, and then I show the result, and I grab this and stick it into my notebook. And here I'm equating powers of x. So I see there's a 4c2x squared, and that better equal 8x squared. So that means 4c2 better equal 8. 4c1x better equal minus 4x, so 4c1 better equal minus 4. And last, 4c0 plus 2c2 better equal 0, the constant term. 3 equations, 3 unknowns. Luckily, relatively easy to solve. I find c2 is 2, c1 is negative 1. And with a little bit of work, I find that c0 is negative 1, which tells me that y3 is going to be this. If I go back, remember I'm trying to write the general solution of this non-homogeneous problem up here. So that is going to be the general solution of the homogeneous problem, in this case c1 cosine 2x plus c2 sine 2x, plus the 3 pieces of the non-homogeneous solution. So here is the homogeneous part, and over here we have, let me blow this up a little bit, over here we have the 3 pieces of the non-homogeneous solution, and this is the general solution. It's not clear entirely what the book meant by use a computer algebra system. This computer algebra system that I've shared with you, cocalc, is actually pretty sophisticated, and one can just solve this directly. Let me walk you through that briefly here. Or solve the differential equation directly. That's going to be again, declaring variables. We're going to do this in x, and I think that's all we need. And then we're going to declare an abstract function, y. And then we're going to build the differential equation. And I've already forgotten what the right-hand side is here. 4 cosine 2x plus 6 cosine x, and last not least 8x squared minus 4x. Just double check that. That looks good. All right. And then I'll just solve it directly using the desolve command. H equals desolve the differential equation, and I want to solve for y, and then let's show h. And if you look at this, you see there's the homogeneous piece, and then the polynomial piece, 2x squared minus x minus 1. It's not sort of kind of all over the place. And then this last piece, we've got our x sine 2x here, and we've got a 1/2 cosine 2x. It looks like there's some trig identities kicking around here, so it's not a perfect match, but these are the same. It's a fun exercise. Take this thing and try to get the non-homogeneous part to match the piece that you've got. Yeah. Anyway, again, not clear what the textbook wants. Do they want you to just solve the whole thing? That's arguably true. In which case you can do that last part that I did. Part A is just find the suitable form. So build the thing with the undetermined coefficients, but Part A is not asking you to find the undetermined coefficients. Part B is saying, okay, now find the solution using that thing that you built in Part A. You can use the first method where you kind of build the equations piece by piece, or you can use the second method where you just get cocalc to solve it directly. Okay.